All right, so week 2 and math 2800. Before going to the question 1, let's have a look at the similar and simpler question related to the question 1, but from math 1120. Now you see this a tank coming with capacity of 1000 liter, 200 liter in it, and a salt water coming in with this concentration, with this speed, which I have shown it here, as I can show this here, the information, and it goes outside with this speed, 5 liter per minute. I have shown it here. The concentration is unknown for us, but we can get it. So if the amount of the salt in water, amount of the salt dissolved in water, if we show that A of t, in some context, it's been shown by M of t. In the determined time t, then A of t is in terms of gram. Yes, we know that. So the rate of the change of the salt will be derivative of the amount of the salt in terms of time. But let's think in this way. If I multiply it, if I multiply this this velocity, I'm sorry that it seems that it's a little bit blurred. Monitor. If the velocity is this one, if the concentration is this one, if I multiply them together, it will be gram per liter and times liter per minute. So the result will be gram per minute. If I multiply them by a time, it will be gram. So that so it means in any determined time, or in any little time, or dt means a small tiny of interval of time. If I sum all of the ct, vt, and times it with the tiny of the time, sum of that, so I will have infinity of the sum because I have chosen a tiny of time. So then this will be, roughly speaking, integral of multiplication c and v. So we have a dt, it means time. That's why the multiplication will be gram after time, multiplying by dt. So taking derivative from the both sides of the equation, that's why derivative of this one, I can write without integral. Velocity times concentration coming in, and definitely, and minus part is almost obvious. It goes outside. It decreases the amount of the salt with this drainage here. So velocity of outside concentration. So this is the original part of the solving the problem. The rest is okay, just substitution. But we just note that concentration of outside, the definition of the concentration is amount of the salt divided by the volume of the water. So volume of the water, we had 200 liter already, and since 10 liter coming here, 5 liter going outside, so the difference is 5 liter per time. The volume of the water increases. So I have to write 200 plus 5t. And in the second part is like 10 liter going outside. It means the volume of the water will be fixed. Therefore, I will just write 200. So a concentration of the water going outside, concentration of the salt in the water, it will be amount of the salt divided by the volume of the water, which is fixed, and it is 200. By this preliminary question, we can go to the question 1. You see that we got 2 tanks. The first one, T1, T2 here, 800 liter water in it, 1000 liter per minute. So the color of the highlighting in the on the words, it's same as the almost with the color of the what I have drawn. 20 gram salt dissolved here, 80 gram dissolved here, and we see that a half gram salt entering to the tank 1. You see this gray color, half gram, 0.5 gram per liter with the speed of the 4 liter per hour. Okay, it's here. There is a connecting pipe. Water flows from tank 2 to the and going to the tank 1. So it 10 liter per hour. Okay, pink one. And the direction of the pipes, it's obvious. And the brownish information. Through a different connecting pipe, the mixture of the flows, flows out 14 liter per hour from tank 1. You see that T1 going outside 14 liter to, so after that just with lower speed 3 liter per hour. With this velocity it goes back to the tank 2. Okay, this is most of the question. The rest is easy because we have good like picture from the question. Tank 1, I show it by amount of the salt index 1. It seems that concentration 0.5 gram per liter times the velocity, which I have written here, plus something come inside also here, the pink color, 10 liter per hour from tank 2. I don't know the concentration, but I can calculate it. Amount of the salt from second tank divided by 1,000. And going outside, this one, this part, 14 minus 14 times A1 of T divided by 800 liter because we have only 800 liter water. So remark, 10 liter coming inside, 4 liter coming inside, and 14 liter from here. It goes outside. Therefore, the volume of the water is fixed. The same thing happening to the tank 2 as well. So similarly, we can write the second ODE for tank 2. So fresh water, 7 liter per hour and 0 concentration because fresh water. So this is redundant, but I prefer to write because I want to have a comprehensive solution. And you see that 3 liter coming inside, so that's why positive, and minus 10 going outside. So the initial value problem, 20 gram here, yellow 80 gram. So they constitute initial value condition for us. Okay, do you have a question about this?
Why do you on the line with BA1, BT at the end? Why do you times the 10 liters per hour by A2 of T over 1,000?
Here, do you see this one?
Yeah.
And 10 liter per hour coming from second tank to here. So velocity is 10 liter per hour and times the concentration of the resource. The resource is second tank.
Right.
And the amount of the salt in the second tank, A2 of T, divided by the capacity of the water in the second tank.
Right.
Okay. Is that clear now?
Yeah.
All right. Any other question about this? All right. Let's focus on the other long question. So according to the remark that I have written for you, you see that if I see something like this, the famous change of variable is this one. u equal to ax plus by plus c. So we will apply this one for the part A and part C. So y prime x minus y plus 1 squared. So I will take u equal to x minus y plus 1. Okay, so I would like to see in your assignment like this type of solution. So we take derivative of in terms of the x from both sides of this one. So it will be u prime equal to 1 minus y prime, which I have written here. Rearranging tells me that y prime equal to 1 minus u prime. Therefore, if I substitute in the original ODE, it means this one. By using this one here, 1 minus u prime equal to u squared. So u prime, the yellow color will be this one, 1 minus u squared, which is what type of equation? It is separable. So integral of 1 over 1 minus u squared. Okay, sorry. So it seems that what's the room of this one? One student went to the other room. Okay. Sorry, guys. So 1 over 1 minus u squared du dx equal 1. So by the separable, solving separable ODEs, so you can see the video in the canvas. I have uploaded there. So integral of 1 over 1 minus u squared u prime dx equal dx. So I integrated from both sides of the this equation in terms of x. By change of variable this one, you are able to write integral of 1 over 1 minus u squared du equal integral of dx. I did one step more, but you can immediately from this side, you can go to this side. Okay. Now, integral of 1 over 1 minus u squared. I can decompose this fraction a over 1 minus u, b over 1 plus u. All right. So I can write 1 equal a times 1 plus u plus 1 minus u. So how am I able to obtain this a? Either by rearranging or by writing this one. So this is equation. This equation is true. This equation true for any value of u. So if u is equal 1, so 1 equal a times 1 plus 1 plus b times 1 minus 1. So this will be 0. Therefore, from here, I will be able to conclude this a equal to 1 over 2. Similarly, by subbing u equal minus 1, I will be able to get b equal 1 over 2. All right. So now back to the original integral. So that integral by after decomposition of the fraction will be this one, half integral of du over 1 minus u plus 1 over 2 integral of du over 1 plus u. So again, I can write this one as u minus 1 minus outside. So this one will be half ln of u minus 1 plus half ln of log of u plus 1. And this one obviously x plus c. So I can write this one as 1 log. Okay. Do you have question about this part? Okay, so what I did is like a log of A minus log of B is equal to log of A over B. Okay, so 1 over 2 ln. All right, this one, multiply everything by 2, then heating by exponential, it will give me u plus 1 divided by u minus 1. By the way, in your assignment, if you don't write absolute value after log, you will lose a mark, some mark, okay? Integral of, for example, this du divided by 1 plus u, it is log of absolute value, not parentheses. Okay, so from star, it means this part, u prime 1 minus u. We can see that we will have some equilibrium solution as well. It means, so this part, you see that 1 minus u squared can be 0. So u equal 1 or u equal minus 1 can satisfy on both sides of the equation. Therefore, u equal 1 or minus 1. They are also solution of the ODE as well. U equal 1 by change of variable, it is equivalent with x minus 1 plus 1. With this one, u minus 1 will be equivalent with this equation. All right, are also solution. We can see that if I take d equals 0 and this side, this and this constant, so this part can u equal minus 1 can be obtained. Okay, so u plus 1, u minus 1, d is 0 here, so this will be minus 1. Okay, but if I take d equal infinity, the denominator can be 0. But d is equal infinity. Infinity is not a real number. Therefore, d is infinity, or d for not any real number, we can get u equal 1. So there is no constant. There is no real constant for this d can show u equal 1 solution. So what's the conclusion? Okay, these things are not written in your written up version solution. So this equation, so well, u will be, what was that, x minus y plus 1. You will substitute it and you know that not all of the solutions can be represented by this equation here. So one of the equilibrium solution has not been represented by this equation that we obtained here. All right, this is first part of the question 2. Do you have a question about this? So I will go to this part. All right, so I go to the part B. So part A is like this. Okay, so part B, fourth order ODE, but it's constant coefficient. So what we do, just quickly, we write the characteristic equation as you see like this. So our job is to understand the roots of this characteristic equation. So so obviously I can take out one of the r's, so it will be this, and the inside parentheses is very familiar to us, and it is nothing except r minus 1 cubed. Okay, so the roots of this characteristic equation will be r equals 0 and r equal 1 3 times. Okay, it's been repeated 3 times. So we have 4 roots. Okay, any algebraic polynomial of degree n, it has n solutions. So we have 1 solution here and 3 solutions. R equal 1, but it has been repeated. R equal 1, R equal 1, R equal 1, 3 times. So the complementary solutions, which is all solutions of the ODE, is y sub c is equal to c1 e to the x plus c2x e to the x plus c3x squared e to the x. So r equal 1 is coming from this side. So if this was alpha, this would be alpha. So it's been repeated. That's why I multiply by a polynomial, which is the simplest one is just x. You can sub it this one by any other linear polynomial, x plus 1, x plus 2, whatever. C3 as well. Why I have written C4 here? Any comments? Yes, excellent. So r equals 0. So C4 e to the times 0 times x, which is 1. So C4. So part C. Y prime equal to cos of x plus y with this initial condition. Okay. Y prime. So again, u equal to x plus y. U prime equal to 1 plus y prime. Therefore, y prime equal to u prime minus 1. So the ODE will be u prime minus 1 equal to cos u, which will be again, so from here, u prime equal, I move this minus 1 to the other side, it will be 1 plus cos u. So again, it's separable ODE, integral of du over 1 plus cos u, integral of dx. When you see integration, including fractions by sine and cos in numerator or denominator, that will be a little bit hard, but there is a famous change of variable. Okay, these are the techniques of solving integration. Although these days we got lots of soft computers that they do the job. So cos u, so what I will do is this, z equal 10 of u over 2. Why I write this one is because cos u is equal to, we know that, I hope this is familiar to you, this identity. Cos u equal to cos squared u over 2 minus cos sine squared u over 2. Yeah? So it's cos 2 theta is cos squared theta minus sine squared theta. From here, we know that cos squared u over 2 plus sine squared u over 2 is equal 1. This is much more famous. So therefore, this one here, it will be cos u squared minus this one divided by 1. Instead of 1, I write this one. Okay. Okay. All right. So now I divide cos u this fraction whole things by cos squared u over 2. So this will be 1. This will be 10 squared u over 2. 1 plus 10 u squared. So I was able to write cos u in terms of 10 u over 2. Like this. So cos, what was 10 u over 2? I assume that it is z. So it will be 1 minus z squared divided by 1 plus z. There is another famous identity that if you remember, so it is 2 sine theta cos theta. I will use this one actually to write sine u in terms of 10 u over 2. So I will do the same technique, divide it by this and divide it again whole fractions by cos squared u over 2. So this will be sine u equal to 2z divided by 1 plus z squared. So now z equal 10 of u over 2 will be z prime equal to half 1 plus 10 squared u over 2 or second squared of u over 2. Now dz over du equal to 1 over 2 times 1 plus z squared. So back to the original equation. I'm sorry that this was a little bit long. Integral of du divided by 1 plus cos u will be this one. I substitute what I have created with this change of variable. Integral of du will be this one. Du, so if I like do cross things, so I will get this one. 1 plus cos u. Instead of cos u, as I said, it will be this one here. By simplification, this will be integral of dz equal integral of dx. So integral of dz is just z or 10 of u over 2 equal to x plus c. Okay. Therefore, this will be, instead of u will be x plus y, 10 of x plus y divided by 2 equal to x plus c. Yes, we are almost done. Initial condition was y of 0 equal pi over 4. So it will be 10 of 0 plus pi over 4 divided by 2 equal to 0, 0 plus c. So c will be 10 of pi over 8, which is equal to third of 2 minus 1. So how I was able actually to get the 10 of u pi over 8, I have written here, and I will try to upload this one in Canvas. Now, so actually 2 theta pi over 4. So what I do is just 10 of 2 theta will be 1. Tangent of theta or tangent of pi over 8 here, and the quadratic formula. So I assume that t equal 10 of theta. So this will be this equation t. Quadratic formula has been used here. So I will get minus 1 plus minus third of 2. Since theta is pi over 8, I will choose the positive version. So for this one, I will choose only plus positive third of 2 minus 1. Alrighty. So extra explanation here. So tangent of x plus y divided by 2 equal to x plus third of 2 minus 1. So again, another challenge. X plus y divided by 2 will be 10 inverse times 10 inverse of x plus third of 2 minus 1 plus k pi. K pi. So y. So this is the tangent c, that's a periodic function. So 10 of u, let's assume that, for example, 10 of u is equal 1 a. So u will be equal 10 inverse of a plus k pi. If a is only in this interval, this part, okay, so k will be 0. In fact, from year 12, Mathematics of Australia. 10 theta equal 10 of A is theta is equal A plus K pi. If it was like cos theta equal cos A, it would be theta equal like A plus 2 K pi. For sine, there are two formulas as well in a almost similar way. Anyway, x plus y divided by 2 is this. This is a comprehensive solution, and I'm sorry that it's too long. So let's have a look at the question. Do you have question about this? You see this non-homogeneous differential equation with constant coefficient. Y double dash plus 2y prime plus 2y. Let's just quickly to do this. Characteristic equation r squared plus 2r plus 2 equals 0. So by this technique, I can get r equal to -1 plus minus I alpha plus. So let's this -1 is alpha and this one beta I. Okay, beta I. All right. So therefore, complementary solution will be e to the alpha x or minus x times c1 cos beta x or cos 1x c2 sine beta x. So this is the complementary solution which is easy peasy. Particular solution, the right hand side was cos 2x. Therefore, the particular solution will look like to the right hand side of the ODE cos 2x. So I will take yp equal to a times cos 2x plus b times sine 2x. So yp prime equal to minus 2a sine 2x plus 2b cos 2x. This one. So yp double dash will be equal to minus 4a cos 2x minus 4b sine 2x. So yp, we chose it to be like particular solution. So yp double dash plus 2yp prime plus 2yp equal to cos 2x. So one by one, yp double dash, yp prime, yp, I will substitute in this ODE. So you see that I will collect cos 2x in somewhere, cos 2x, cos 2x, cos 2x. So minus 4a, 4b here, and plus 2a here, and times cos 2x. Similarly, for sine 2x, the constants, the coefficients will be gathered here, and sine 2x is equal to cos 2x. So the right hand side is cos 2x, and therefore this bracket will be 1, this bracket will be 0. And I'm sure that you remember these things from Math 1120 or Math 2310. Now, so what I said, I have written here 4b minus 2a by little bit simplification, and I'm able easily to get b equal to 1/5, and a will be minus 1 over 10. So therefore, yp will be this one, and the overall general solution will be summation of y sub c plus yp. So I have written it here. Do you have a question from this? So we have a consultation time, just a kind reminder for you that 12:30 until 1:30 in SR 245. 241, sorry. 245 is my office. Now, before going to do the question 3, from Math 2310, like week 4 or 5, you would see this question that suppose that a virus there was in campus and a student carrying that virus, and so 1,000 students in campus. After 4 days, we have 50 students like getting this virus. So susceptible infectious model or population growth or birth death model. I'm not sure for the last one. Tells me that so x prime equal so the rate of the change of the population has a direct relation with the population itself. It means x prime has relation with x. Okay. Without referring to this susceptible infectious model, I can write this one. Just little bit thinking needed. So x prime equal rx. The initial condition was x of 0 is equal 1 because we had only one student. And the separable, this is a separable ODE. So x of t will be a times e to the rt. R is the rate of, we will see. Yeah, so e to the rt. I have another highlighted information, the red one, okay. E to the 4r equal 50. So I can get r, I can calculate r. So I'm able to calculate x of 6 equal 354. So you see that actually this is the general solution is the exponential. And if my initial value is 1, then it's starting and growing. But in fact, this is not realistic because we have only 1,000 students. We have limited resources. So even if it is the population of some species, we don't have infinity resources. So it will stop somewhere. Therefore, we need to investigate some other model. So I will put some limitation, truncation here. I will call it K, okay? So I will think that it will, if it starts from the down, it will go up and it will stop here on the K. K is a place that the growth, the rate of the change of the growth will be stopped, will be 0. Or if it's like too much, because we have limited resources. From the top, it will decrease and it will stop in the K, okay? So similarly, so this has the, it's not the, what I said, it's not the proof of this this one, x prime t equal rx, this one logistic differential equation model, but somehow it is understandable. For example, if it is x equals 0 here, so this model will be x prime equal rx. So if x is 0, it will be old model. If it is x equal k, this will be 0. So the x prime will be 0. All right. So if it is x more than k, this will be decreasing. So the x prime will be negative. So which is compatible with what I have drawn here. Question 3. A fisheries biologist maximizes her fishing yield by maintaining a population of the lake exactly with 500 individuals. Okay. So she wants to keep it like 500 individuals, but like the maximum, the capacity might be something more. So with this logistic differential equation model with R equal 5 over 5 1,000s, let's assume that we have 600 fish more than whatever that she wants to keep the individuals. So it means we have 1,100. The R is 5,000s. So K, as I said, K is the limitation, maximum of here. So F prime X. this f of x, the rate of the change must be 0. Okay, so let's assume that this is f of x. So f prime x equals 0. So if I take a derivative, I will get this one. So with some simplification, I will get x equal to k over 2. So x is 500. We are like somehow here. And I want to get this k. So this k will be 1000. Now, the question asks us the calculate x prime. So for what rest of the so I will put just the rest of the formula. 5000, x is 1100, 1 minus 1100 divided by 1000. So it will be, the answer will be minus 5500. So we are almost here. And we want to decrease it. So it's almost every other day we can catch one fish, and then we will get the capacity k. We will get the 500 because what we have assume that k is 1000, and we calculated k by assuming that we want x to be 500. So that's why k is 1000. And what in the right now we do have 1100. So we will get this one. But so the proof of this one can be, you can Google that. There are lots of stories going on. Okay. Now look at this one, x prime equal to rx times 1. So this type of equation is like y prime equal to f of y. Okay, so this is like this is an autonomous system, ordinary differential equation of example. So for example, this one, y prime equal y times y minus 5. So f of y. So what are the equilibrium solutions? Are this y equals 0, y equals 5. It's just the roots of the right hand side. So you will have one question similarly to this one in your assignment probably. So how can so the stability and unstability of the equilibrium solutions can be determined by two ways. One of the ways is using the second derivative test, the second derivative of y prime or first derivative of f. So if I take it, so f prime y will be 2y minus 5. If I sub equals 0 in this, I will get minus 5 less than 0. So this means this 0 is stable. Unstable when f prime of 5 is more than 0. It means unstable, what does it mean? It means the solutions moving away from that. Stable means the solutions getting attracted to that. Here, y, this one, 1 minus x over k, x equal k is a stable solution. All the solutions tending to approach to this k, x equal k. And x equals 0 or x equal x0 is a place that other solutions moving away from that. So x equal x0 is the unstable equilibrium solution. Question 4. Last question. Sorry. So this time, unlike question 1, we have 3 tanks. We have joined together, each containing, so tank A, B, C. Okay, so tank A, B, C. So pink one, I have shown it this pipe here and this pipe here. Each of them has got like 100 liter. So The other highlighted one is related to from fresh water coming inside to the tank A. This one. So this is the corresponding column is this one, fresh water, 4 liters per minute. What concentration of the fresh water is 0. So 0 concentration because it doesn't have salt. Green one, the rate of the 6 liters per minute. It's from tank A going into the tank B, 6 liters per minute. And the dark green is like tank B is pumping into the tank C with this 5 liters per minute. I have it's written here, and pumping back into the tank A with another pipe, 2 liters per minute. And the last one, mixture from tank C is pumped out at the rate of 5, not 4. 4 is written, 4 is a mistake there. Okay, 5. It's going outside and then it's coming back with a lower velocity, 1 liter per minute, and it's going back to the tank B. So let's have a look at the tank B. 1 liter coming inside, 6 liters coming inside, totally 7 liters coming inside. Now, look at the dark green. So 5 liters going away, 2 liters going away. So totally 7 liters going out, 7 liters coming inside. So it means the 100 liter will be fixed. So we have easy job. So let's have a look at the one of the differential equation, tank A. So you see that 0 times 4 liters per minute. Why I have written 0? Because the concentration of the salt in the fresh water is 0, I hope. Plus 2 liters coming inside, 2 liter velocity times concentration of the resource from here. It should be xp of t divided by 100. Okay. 2 liters is the velocity is written here. Minus 6. This one. Concentration is x of a divided by 100 times velocity, 6 liters per minute. So for tank B, 1, 2, 3, 4. 4 expression I have, and accordingly you can figure out what's going on. Tank C. Tank C is the lazy one. For 5 liters coming inside and 5 liters going outside. So xp of t. So 5 liters coming inside, that's why it will be positive. Positive 5. Concentration resource is there B. This one. And going outside 5 liters. Resources is itself. xc of t over 100. So it's for today. So tutorial session. Please let me know if you have questions. Do you have question? So let's look at this one. Y prime is equal to y times y minus 1. So this is, so the equilibrium solution will be y equals 0, y equal 1. I'm not talking about general solution. This is not general, so it's separable, it's solvable, it's okay. So this part, let's call this one let's write this y equal 1, y equal 0. This here is y. Here is y minus 1. And here is y prime. So y is more than 1 is positive, more than 0 is positive, and here y less than 0 is negative. Y minus 1, more than 1 is positive, negative here, okay? So positive, positive will be positive. So the solutions of the y prime here, it's multiplication of these two. That's why positive times positive. So it's increasing here. We have a positive slope. Positive slope. Positive minus, it's decreasing here. Minus, sorry. That will be positive. So it's new column. So negative, it's this one. Negative, negative is positive, so it's increasing. So the solutions is like probably like this, probably like this. So this one is stable. This one is moving away. So this one is unstable. All right, this is another way. So here I said the way of that we determine stable and unstability is second derivative of this one, y double dash, or f prime y here is second derivative of this one is equal to first derivative of this right hand side. This is one way, and this is another way to say that which one is unstable and which one is stable. Stable is important. Why? Because all the solutions by the time it's going to approach to the stable solutions. I hope you learned something for today. And sorry, because there is like lots of information here. All right, so it seems that there is another class after us. We should leave soon. Have a good day ahead.